Good morning, everyone. Today, we will be discussing about the plate tectonics, and this is mainly prepared by Abigail Arsenal, Josamea Gohayon, and R. Joseph Asuncion. This is Abigail, and I am the first one to discuss about the lesson. Here is the lesson learning objectives. To define the plate tectonics, distinguish its theory, recognize the three types of boundaries and its causes and effects. Plate tectonics. A plate is a large, rigid slab of solid rock. Plates are formed from the lithosphere, the crust, and the upper part of the mantle. It is a scientific theory that explains how major landforms are created as a result of Earth's subterranean movements. What drives plate tectonics? The forces that drive plate tectonics include convection in the mantle, ridge push, and slab pull. So, this is the Earth's plates. The largest is the Pacific Plate, which is located mostly within the ocean proper, while the Juan de Fuca Plate is the smallest of Earth's tectonic plates. It is located west of Washington State in British Columbia, under the Pacific Ocean. Next, here are the three types of boundaries. We have divergent boundary, convergent boundary, and transform boundary. The plates collide, pull apart, or scrape against each other. First boundary, we have divergent boundary, where two plates move apart, resulting in a swelling of material from the mantle to create new seafloor. One of the examples of the divergent boundary is the Mid-Atlantic Ridge, where the Eurasian plate that covers all of Europe separates from the North American plate. This is the illustration of divergent boundary. Rising magma upwards the crust, causing numerous cracks in the rigid lithosphere. As the crust pulled apart, large slabs of rock sink, generating a rift zone. Further spreading generates a narrow sea. Eventually, an expansive ocean basin and ridge system are created.
And now let's move on to convergent boundaries. What is a convergent boundary? Well, imagine the world is like an egg, with a shell that is cracked all over. Just like these cracked pieces of eggshell, the entire outer crust of the Earth is broken down into sections, called tectonic plates. But instead of resting on liquid egg yolk, these plates float on a sea of hot magma, something you'd only actually see in rare events like volcanoes. This magma is not a liquid, it is actually solid. But under the incredible pressure beneath the Earth's crust, even solids flows like honey. The crack in the egg or boundaries between plates, a convergent boundary, or a destructive margin, since this is where collision between two plates occur. The pressure and friction is great enough at these boundaries that the material in the Earth's mantle can melt, and both earthquakes and volcanoes happen nearby. There are three types of convergence: the oceanic-oceanic, oceanic-continental, and continental-continental convergence. Now let's talk first about the oceanic-oceanic convergence. When two oceanic plates collide, the denser plate sinks below the lighter plate and eventually forms dark, heavy, basaltic volcanic arcs. The western half of the Pacific Ring of Fire is full of these volcanic island arcs. When oceanic plates are subducted, they often bend, resulting in the formation of oceanic trenches. These often run parallel to volcanic arcs and extend deep beneath the surrounding terrain. The deepest oceanic trench is the Mariana Trench. It is more than 35,000 feet below sea level. It is the result of the Pacific Plate moving beneath the Mariana Plate. The second type of convergence is the oceanic-continental convergence. When oceanic and continental plates collide, the oceanic plate undergoes subduction and volcanic arcs arise on land. These volcanoes release lava with chemical traces of the continental crust they rise through. The Cascade Mountains of western North America and the Andes of western South America features such active volcanoes. Oceanic plates are denser than continental plates, which means they have a higher subduction potential. They are constantly being pulled into the mantle, where they are melted and recycled into a new magma. The oldest oceanic plates are also the coldest, as they have moved away from the heat sources such as divergent boundaries and a hot spot. This makes them denser and more likely to subduct. The third type of convergence is the continental-continental convergence. In continental-continental convergence, two plates collide, but instead of one plate sinking beneath the other, folding occurs and mountain ranges are formed. These result in a very little subduction, as most of the rock is too tight to be carried away very far down into the dense mantle. Instead, the continental crust at these convergent boundaries gets folded and thickened, forming great mountain chains of uplifted rock. The Himalayas and the Tibetan Plateau, the result of 50 million years of collision between the Indian and Eurasian plates, are the most spectacular manifestation of this type of boundary. The jug peaks of the Himalayas are the highest in the world, with Mount Everest reaching 29,029 feet and more than 35 other mountains exceeding 25,000 feet. The Tibetan Plateau, which encompasses approximately 1,000 square miles of land north of the Himalayas, average around 15,000 feet in elevation.
Now, let's talk about the last boundary or the transform boundary. So what is transform boundary? A transform boundary is when two tectonic plates of the Earth pass one another. The interaction between the two plates as they pass one another might result in localized faults or fissures. The majority of transform faults are in the ocean, where they offset spreading ridges to create a zigzag pattern between plates. Here is an illustration of transform boundary. The left and right plates are passing one another. As shown in the image, this is due to the plates' motions at the transform plate borders, which are either divergent or convergent, or moving in the same direction but at varying speeds. Here is an example of a transform boundary. It is called the San Andreas Fault. A continental transform fault runs through California in the United States for around 1,200 kilometers or 750 miles. Its right lateral strike-slip motion creates a tectonic border between the Pacific and North American plates. Let's now discuss the cause and effects of tectonic plates. What causes the movements of the tectonic plates? In the Earth's mantle, convection currents are produced as heated materials rises, cools, and then falls back into the core. This current drives the tectonic plate action in the crust. Ridge push is one of the factors that create tectonic plates. Ridge push, one of the two primary driving forces for the movement of lithosphere plates, is a hypothesized force resulting from the horizontal spreading of the near surface asthenosphere along constructive edges. Slab pull is another factor in the tectonic plate movement. As a result of increased densities, slab pull is tectonic plate motion. The weight of cold, thick plates descending into the mantle at trenches contributes to plate movement. Now, let's talk about the effects of plate tectonics. Earthquakes are one of the effects of plate tectonics. A false abrupt slippage brings on an earthquake. Although the tectonic plates are constantly moving slowly, the friction causes them to become stuck at their edges. An earthquake occurs when the tension at the border overpowers the conflict, releasing energy from waves that travel through the Earth's crust and generate the shaking we experience. Earthquakes also cause tsunamis to develop. The ground underneath the water is quickly shifted up and down during an earthquake, and as a result of this movement, a large volume of water is displaced and begins to travel in all directions. The form of mountains is another effect of plate tectonics. Mountains caused created in the processes are related to large-scale changes in the Earth's crust. The orogenic process of creating mountains can include bending, faulting, volcanic activity, igneous intrusion, and metamorphism. And that's all about the discussion of plate boundaries, and I hope you understand something. Thank you so much for listening, and Birahi, PSME.